Let us now look at another property. We still have property of exponents, but look at right now our base is an exponent of its own. Well, if you look at just x to the third power, remember what that actually means is x times x times x. But if we square it, remember since we have parentheses, that entire x times x times x is now my base of that exponent of 2, which means x times x times x times x times x times x. Notice that base times itself leaves me x times x times x times x times x, which is, by definition, x to the sixth power. This is the time we multiply exponents. That's our shortcut. Now again, we don't normally want to expand those out. That isn't how we normally want to proceed through a problem like this. This has a name. It's what's called power of a power. And again, don't worry about the names on these. What this means is, if I have a to the n power, that means a to the n times n power. So when we see a problem, similar to the last set of problems, 5 to the 8th to the 10th power, what that has to do with is this is when we multiply those two exponents, 5 to the 80th. Again, some we definitely wouldn't want to compute by hand, but these are why we use these shortcuts. What if we have x to the 5th cubed times x to the 7th? Well, when we go through our order of operations now, when we look at that x to the 5th cubed, looking at this power of a power alone, this right now is when we multiply exponents. But remember that when we have that x to the 7th, this is when we have the two different bases, each different term, each with their own exponent. That's the big difference between last time. Even if I want to put this kind of a thing in parentheses, don't always think, and a common question we get as teachers is, just because we have parentheses, students want to try multiplying those exponents. That's like that middle example problem we had last video. Don't be confused that just because we have parentheses, we want to multiply. I can put parentheses. Parentheses mean multiply. But just because we have parentheses doesn't mean I multiply my exponents. I have x to the 15th, meaning 15 total x's. X to the 7th, meaning 7 total x's. How many x's do I have? 22 of them. And it's really important that we establish that difference of when do I multiply exponents versus when do I add the exponents. It has to do with, notice that I have one base, two exponents. That exponent is immediately applying to that parenthesis of that term. Well, when we look down at this problem, notice that when I'm adding exponents is when I have two bases, two terms. It needs to be the same base, but each of them have their own exponent. That's when I add. Well, let's look at the next problem. What if I had x to the 5th cubed times y to the 7th? Well, power of a power, multiply my two exponents, one base, two exponents, that exponent just outside the parentheses, times y to the 7th. Common, students want to say, okay, well, xy, I want to add my exponents, 22nd. Let me show why that would be a wrong answer. Notice that what we have here is, this would be 15 total x's. This would be 7 total y's. Notice that if we try adding the exponents right now, what this would have said was, I have one single x, I have 22 y's. Notice the big difference in why that's wrong, and we see that happen a lot. Sometimes students even want to put those in parentheses. What this would mean is 22 total x's and 22 total y's. Again, if that's not the same base, there's no adding those exponents. We can only add the exponents when it's the same base.